we were discussing about the projection of points on this all the four quadrants what we had discussed yesterday in first, second, third or fourth. Right? Now this projection of lines, the same plane, I just told about four types of options, that any line you can take in both the ways. You can have this vertical VP and horizontal HP. Okay, then this line can be parallel to both vertical plane and horizontal plane, one point. If you turn like this, it becomes perpendicular to vertical plane and it's even parallel to HP. This is another option. And this you can keep it like this, it becomes perpendicular to the horizontal plane and parallel to the vertical plane. This was three types I told her. Now what happens is, you just look at this figure. This is one indication, that is a picture of your horizontal plane and vertical plane. Here what I did is just taken a line, a consideration of a line PQ. This line, say suppose this pencil is the line, it is the line, it's kept like this. If this picture is drawn in a, say suppose an example of, it's kept some different angle, some 30 or 40 degrees, because you cannot draw a picture in a two-dimensional board or a paper other than this fashion. You cannot draw it. In the straight line it won't come. You won't look at picture in the inclined fashion. That's why it's drawn. And nothing other but, so this is 3, P and Q is one line. So these lines, front view, that is whatever you see from here, this line's front view is directly this PQ can be seen. See, actually I am holding the pencil like this. It's parallel point P and PQ. Vertically see, in the front view it is straight line, directly a straight line. Point P here and Q here. That's what I have written. This is actually the pencil position, but that line's front view is drawn in VP. So I'll write one point, it is P dash, and this will be Q dash. This is how we denote. This is for the front view. I can say it's a VP or front view, HP or top view, as we discussed in previous section. Now, in this top view, whatever you view from the top, that means you feel that your eye, that is the observer, is from the top. When you see from the top, and again it is a line only, same P and Q, you will be drawing it in the bottom, because common idea is that you cannot draw the top view anywhere in the board. It has to be in the bottom. That's what. So this becomes, I'll say from the top when you view this line, it's P and Q only. So I'll write this P and Q here. It is just an indication of a line which is parallel to both vertical plane and horizontal plane. One option. Then perpendicular means, I told you, you can just hold it like this. Now it becomes a front view perpendicular to VP, but when you see in the top view, it is parallel to HP. Second option. And third one, you hold it like this. Now what happens? Front view is perpendicular parallel to VP actually, and when you come to the top view, you see this line, it will be perpendicular to HP. So this is three options completed. Now, how can we position a line in various different points or different positions? So these are the 5 common positions for any line, wherein we can, more than this it is possible, but for which you need the, this is VP and HP. Other planes, it can be all from this side. You have only vertical and horizontal. You can have a side view also. When it comes for side view, you can go more than 5th option. But basically, if you learn about this 5 options, 1, 2, 3 and 4 and 5, it'll be comfortable, right? Now, the first one is parallel to both the planes. That's what I told you, this option. You just hold this pencil, parallel to VP, parallel to HP. First option. That's very simple. You can draw it like this. But actually, while drawing in the drawing sheet, what will you do? You draw a line like this, your common XY line. Now you write vertical plane in the top, horizontal in the bottom. Yeah, parallel. How will you denote? Parallel line is simply here. For front view you see parallel, simply front view, you are drawing it here. It is P dash and Q dash. And top view also, it's again PQ only, parallel. I am telling parallel option. This parallel and this also parallel. It being like this. So the rules is, I told you, with a thin line you have to join these edges, because it becomes this projection only, this line. So again it's P and Q. Okay. Now this line is a first option parallel to both the planes. Now what will I do? I'll go for the next point, something called contained by one or both the planes. What does it mean of containing? It has to be in one plane or both the planes. How is that possible? In the sense, even this I can say it is contained by both the planes, meaning this line is in VP, also in HP. That's one point. But which can be, see, this distance is specified, maybe it is 10 or 20, whatever the number, or this may be 30. If this distance is not required, that means I'll draw another line, XP, X and Y, VP and HP, the content, instead of having this PQ in this point, I can bring it to this, on top of XY line, because anyhow the position is like this, is vertical plane, horizontal plane. This is my line. This can either sit in this XY point, line of midline XY. It becomes contained of both VP and HP. So I'll write this PQ is here, P is here and Q is here. Is that okay? Actually, what is this position means? This is a line. Here itself I can write P dash, Q dash as well as PQ. That means it is contained on both VP and HP. This is also one option, this other option. But here we say it is parallel to both the planes. Why it is so? When you hold it, this comes in this distance, it's parallel to HP, parallel to VP. And we specify this, the distance, the gap between this point and this point, the line and the plane. At this first point it is. But here there is no difference of the distance from this plane to the line. It is lying on the same plane. The XY is the combination of your VP and HP, common point. On that only it is lying. It's one point. So containing means it is contained on that. There is no gap between the XY line and the line's position, which means it's called containing. Contained by one or both the planes. Here I would say it is contained on both the planes, because it is on VP as well as HP together. Now if I say contained on one but not contained on the other, how would you do it? As I was just telling about, see this parallel line. If this is P and Q, I would rotate this line like this. With wherever position I rotate like this or this P remains as it is. Q is actually rotating or inclined. This inclination cannot be seen in your front view. See, the inclination can only be seen through top. When you keep your eye here and see, you can see what is the arc of rotation here. This inclination can be seen here. But when you see in the front, you see a point P and Q, but Q may be coming here. When you see from there, you can see one point on one point here. You cannot differentiate this distance. Is that okay? So that becomes another line contained by one. That means I'll just write like this. Again X and Y. Okay. VP and HP. Now I'll do just a line P and its Q. I have a distance of suppose 10 centimeter or whatever it is, and next one when you come down here, see, I can take it like this, which means I will say it is parallel to VP but inclined to HP. In the sense, this line is now parallel to both the planes, VP and HP. When I rotate it like this or like this, say suppose, this inclination, I told you, you cannot see from the front view, which means you can see point P is here, Q is here. You will see one point here, one point here. Join just 2 points, it becomes a line, straight line again. So this is P and Q. But actually, when I see from the top, this inclination can be seen. That means it was here before, but inclined, and you can see this inclination line. That is here. Actually, it should be like this, exactly straight. But I won't specify that because in the top view, this is the top view, because whatever we draw it in the top view comes in HP. This is TV, top view. It will be looking like this. So this becomes contained in one plane by one plane or both the planes. Since both the planes means like this, because it has to be on both the planes. Contained by one means it is contained on one inclined to other. Right? So that is your second option. The third one, parallel to one and perpendicular to other. How do you say? This is again parallel. Both parallel to VP and HP. Now it is parallel to HP, this parallel, perpendicular to VP. Now what will I do this? Again one more diagram for this one. Okay. So that is, I'll just do it. Say suppose I draw a line here, X and Y, VP and HP. It is what says? It is parallel to one, perpendicular to the other. You keep the line as it is. It is parallel to VP. No, parallel to HP also. Now I will turn it like this. Parallel to HP, perpendicular to VP. What will you see from the front view actually? You will see a point. This is just a point. I will write a point here. But this distance from the floor or from the XY line is XY line. It just XY line is the combination of this vertical wall and the horizontal floor is this XY line. From this, the distance is supposed to, that can be given in the question. It will be some 10, millimeter or centimeter, whatever it is. Now it is perpendicular to, VP. That means I just denote a point. This point is P. Right? And what will you see from the top view? You see a full line, P and Q. Right? From top view, it shows we are drawing in the HP. I draw it here. From the top, it should be like this. Is that right? It is not right because you are looking from here. The first point you see it here, the second point here. This is in the position of like this. Okay, that means I can hold it. Say suppose this duster is like this. I can just hold it like this. From the point P here and Q here. But actually in the drawing sheet it has become like this. Because vertical plane is like this. But horizontal is inactual, it is a board, it is the paper, it comes like this. So what will happen? This duster is shown like this, P and Q, but actually to say it becomes like this. Because the whole plane is being 90-degree rotated. Right? So it becomes like this. So point P is here and Q is here. Now how do I draw it again? This is not correct. It has to be P point is here and Q is somewhere here. That's what you draw from the top view. Now this point is just a point from perpendicular line. It is point in the vertical plane. Horizontal plane, actually it is like this only. When you see from the top, it looks like this. But you draw it in the sheet, how do you draw? It is come like this. Because it's the paper. You cannot keep it like this. This position you cannot keep a paper. You have to draw it like this. XY line, front and top view. This becomes like this. So here also you have to draw one joining, but remember a line will have 2 points, which is that P and Q. But I have indicated P only here, but down it is P as well as Q. Is it okay? Now this P point I have shown, but where is the Q point? P is here. I have just seen the P point. Q is actually hiding. What is hiding means hidden. You cannot see that. It won't come into picture. It comes in the back side of this. How will I denote it? I'll just denote it like this and put a bracket. Something, any letter inside the bracket, which means it is not visible to the direct eye, it becomes the back side. That means it is the hidden point. Right? So it comes like back side. It is, so anyone who just go through this and see this, the right 2 points means you will have to understand that point P and Q are 2 points that have been joined by a line. Since the line is like this position, it is perpendicular to vertical plane, okay, and parallel to horizontal plane. The perpendicular line has been written as P and Q, and the back side, which is an invisible point, is denoted within the bracket. It's clear? Very important to understand the letter which we write inside the bracket means it is invisible or it is behind. Sorry, it's invisible. Now this becomes what? P and Q in the top view, I can see this line, I'll draw it here. Okay, if, see, suppose if this line is like this, we will come to this option, right? From the top view, if you see P and Q is here. Since the line is like this, which is makes perpendicular to VP and parallel to HP, I have to write in this fashion. This you have to understand. Actually, P is here, Q is here actually. But your paper has to be tilted like this. Because you are drawing in 2 dimension. It's all in 2D. 2-dimensional view. You don't have a 3-dimension here. So kindly understand, point P is visible, Q is invisible, which is in the back side, which is in the front view because it's perpendicular like this. But when you see from the top, this P is here and Q is here, you draw it here and this. So the length of the line will be, they will give a line of length, suppose 40 millimeter, 30 millimeter, whatever it can be possible. Is it okay? That's fine. So option number 1 is over, parallel to both the planes. Contained by 1 and both the planes is over. Third one, parallel to one plane and perpendicular to other. It's what I told you. So this for the option what? This option is for directly looking perpendicular to VP and parallel to HP. What will be the other option now? I just put it like this. Now this is perpendicular to HP, parallel to VP, opposite of this. Again, what will I do? The same sketch, a little bit change. Now shall I, this I can take out because we understood what is perpendicular to VP and parallel to HP. This I will be changing into the next position, which is perpendicular to HP and parallel to VP. You write VP and HP is common. You have to fix up. Initially when you start the drawing, remember you have to write a line, you indicate X and Y, immediately write VP, vertical plane, horizontal plane. These you will get marks. You will get 5 marks for this when you specify with a proper pencil and draw it in the proper manner, X, Y neatly and indicate VP and HP. Please remember that. Fine. Now what is the option now? You are holding the line. Line is perpendicular to HP but parallel to VP. From the front view, we have 2 views normally. Please keep in mind we have 2 views. Front view is this. How can I see? P is in Q is there. A straight line. I will draw a line like this. I draw Q, P and Q. For the length of the line, please don't worry. You can fix it to any line as you wish. Now, this from front. But from the top, what will I see? From the top, if my eyes is here, no, I look from here, I see a point only. The back point will be hidden. Same case. I will draw it. Maybe P can be seen, Q will be hidden. I will write hidden. You know? And you remember I told you, inside the bracket whatever you write, which means it's invisible. Fine? Now, this is option. Now what see, you just join this. See, joining is very, very important. I told you, this is the projector. You have to project the line. It's called projector. Anyhow, this is for all. LED diagram, you have to project it. Just to join it. It's called projectors. Okay? So this is an option of what? It is perpendicular to HP, parallel to VP. So what happened now? First point is complete, parallel to both the planes. Second one, contained by one or both the planes. Contained by both means this option. It is lying on HP as well as VP. Same line. Now, contained by one is, it contained on one and maybe inclined to other. It can even have vice versa also. This can come in top inclined and parallel. That's third option. Now again here, parallel to one, perpendicular to other. This I have drawn 2 sketches. The previous one was opposite to this, and this is the what we drawn now. Then we go for parallel to one and inclined to other. Again, when I come to this option number 4, this is another option of, I can say, bring it directly here. Okay? I can see, you can simply view that it's the line. This line is parallel to VP in the front view. But when you see from the top, if I rotate it like this inclination can be shown. This is the inclination. Actually, it should be like this. This is the arc actually. Rotation what we made. So parallel to one, inclined to other. Parallel to VP it is. When you see this in front view, see from the top it is inclined to HP. What is the opposite one? I'll make it. Yeah, shall I rub this one? Yeah. here. Now this is again XY. Okay, this is VP and HP. Parallel to VP, inclined to HP. Please kindly think, it's parallel to VP, rotated, but you can see P and Q, that is as it is. Okay. Now, I'll draw a line like this and one line like this. And what happened to this one? Same thing, P, Q. Here also it's P, Q only. No change. This P dash and Q dash. Is it okay? Now it is what? This inclination, that is, it is parallel to HP actually. VP inclination is what? I'll see from here. You hold the line like this. If you are rotated like this fashion, this angle of rotation can be seen only in the front view. Is it right? When you see from the top, it may be rotated here like this, but I see 1 point here, 1 point here. This inclination cannot be seen. So I will just write 1 point here, 1 point, just join it. It becomes a straight line. Just see from the top, it is top view. See from the front actually, I can see this rotation, this arc. Either it is down or up, it is, and we fix it. You are interested to rotate it up or down, you can, either Q can come down or P can go up. Just vice versa, okay? So it becomes like this. So this option of this one and this one is joined of parallel to one and inclined to other. Okay? The last one is called inclined to both the planes. See, kindly note, when a line is parallel, say suppose this is a 15 centimeters, half a scale, 15 centimeters. When I rotate it, when I make it inclined, this 15 centimeter when it is straight, in the means to say, if this is 15 centimeter here, okay, that cannot be 15 centimeter in the inclined position. That is a common idea, common sense I can say. Because if this is only a 15 centimeter straight line, this is also 15, but when I have a rotation like this, when an arc is like this will be a foreshortened. Either it is a reduced one or it may be an extended one. So we call which line which is actual to the proper length decided is called a true length. True length. Or I would say it is not actually true length at this condition. Why? Because we are actually rotating a line, right? We are not holding a line of 15 centimeter. We are just having a line, maybe 15 centimeter, but when we rotate it, it is the actual picture where we are seeing from the top view. I am talking about, okay, I talk about this sketch because in the top view only we have this inclined position, right? When you rotate it like this, the rotation only, the line is, length is 15 centimeter here. But in the front view only you see the point P and Q. This, it looks like this, this position it is. But actually is this. I rotated. So this is the foreshortened length. But the 15 centimeter remains as it is, but this is the shortened length. So I will say the straight line, whatever you see, maybe it is, this is the length of the line after LENGTH. Length of line at front view. Because in the front view look, it's straight. Actually it's inclined, But we can see from the top, you see this inclination, which is this. This is the true length. True length of the line, length at, I will say at, top view. TV. It is front view, it is length of the line only. It is either will be less or more. But in the top view only you see the true length. Actually it is inclined, but 15 centimeter remains as it is. But in the front view it is not 15 because it is turned, you see only the point, this point and this point. It may not be 15 because it is just come here. Okay, that is the point. Now, inclined to both the planes is the option where it has to be inclined to HP also, where we see the inclination. From the top view only we see the inclination of HP, remember. And inclined to VP means you rotate like this. Okay, straight line, rotate like this. This inclination. Actually, to say how do we view it, I'll go for that option. Drawing it very simply. I should have a line to satisfy this condition. Condition number 5th. I have to satisfy. Say suppose this is the line inclined to VP in the front view. Yeah, it should be like this. Rotation from here. I'll draw a line. Maybe like this. E is kept as it is and Q is. It is this rotation. This is inclined to VP. Front view you can see. But inclined to top view means it should be like this. Holding it strong here. Either this way or this kind of way. So this it has to come. It can either come like this. Kindly remember, this line is called projector line. Image of that one in the opposite side. Nothing. Okay. It's just the projection of point P as P dash or Q as Q dash. Sorry, no. Always write the dash in the front view. P and Q here. Okay. This is the line. Now, this drawing cannot be done like this, because here we make at least one view parallel. In the sense, we have a straight line here that is in one view, that is vertical plane. Other will be inclined. Okay. But when actually speaking, this line has to be like this first, then inclined. Right? Same case, this line has to be basically it's kept straight, right? Straight, then inclined. Then it becomes like this. Okay, like this. So you have a set of procedure to bring a line from a straight position to an inclined position. That is option number 5. Unit number 1, 2, 3, 4. All this should have a combined process to bring number 5th option. That is inclined to both the planes. It will come like this. For this, you cannot simply draw a line of 50 centimeter or 100 centimeter. Just keep it line and make it. You have a procedure for this. How do we bring it? Okay, that I'll tell you. Say for example, you hold a compass. This is an inclined line. Hold the compass like this. Rotate it. What will happen? See, you have a compass. Rotate it. It becomes like this. It come and touch point here. Now I say the touching point, this touching point of P, again say it's Q and Q double dash. This will become a straight line now. Actually it is inclined, right? It is like this. When I fix this point P and rotate Q, now it becomes a straight line like this. Maybe, but this is 15 means it may not be 15. It may be 16, 20, or if it is started or length. Then you don't worry. This procedure. Now what do I do? In the opposite side, I have another line, in the sense, which is supposed to be a straight point. This point, wherever after rotation it comes to Q double dash, this can be brought it directly down with the scale. Straight, you pull it down. That is perpendicular. Straight down. This will come and touch point here. Okay. And this point could be joined with this line here. I mean to say, in the front view, if it is inclined, to make it a straight line, because you know that you may not have a true length at all the places. You should find out its inclined positions length, foreshortened length or extended length. You are rotating it here and bring it down. In the same fashion, this line can be rotated how? I'm just telling an example. We shall go for a different type of lines using the question in the further steps. Now here, this can be brought it. I'll brought it here. It's a compass. I'm just telling, not telling it has to meet it here, because this is different and this is different. This line is brought it here, bring it down, straight. And this line, say suppose take a compass in this arrow mark, this direction. From here, if you bring it, say suppose XY is like this. I'll make it a bit clear by writing, XY. After rotation here, I'll say this Q, again it is Q1. Don't put dash on the top view. Please differentiate the notation between top and front views always. It will be easier for you to understand. So this P and Q, this you can bring it to the top. Is it okay? So this point. Now what happens? This inclined lines, straight line can be this, and this inclined lines straight position can be this. This is how we find out the actual length of an inclined line. You know, inclined to both the planes. A line is inclined to both VP and HP. That line's actual length we are finding out in this method. To be still precise, we will have another methods. There are 2 or 3 methods of this term. It's using a diagram, you know, using a question. See, instead of speaking everything by a normal, you know, common idea, if I pose a question, that means a line of length PQ having a length of 30 centimeter, which lies on HP, inclined to an angle of, no, it's inclination. When you speak, obviously you have to give this angle, right? Which is 30 or 40 or 50 or whatever degrees, within 90, 0 to 90, 90 becomes perpendicular. I have to say specify an inclination angle, so which I will tell you, maybe it's 30, 40. With this inclination, we will see another question. Okay, that would be still better. So kindly remember, you have only 1, 2, 3, 4, 5. These 4 or 5 options are very important to know about a line. Okay.